Okay, so what we're going to do today is we're going to look at another sample experiment. Okay. I don't know why that's showing presenter view up there, but there aren't any notes, so as long as you can see, you'll be fine. So a statistical experiment sample. So we're going to do the same type of thing that we did last time, where we're going to get given a scenario. You're going to then answer some questions based on that scenario. What kind of experiment can you design? What question might you ask, etc. All right? You may work in groups, that's fine, right? But I want to see a result at the end. Right? So these are things that I'm going to see. So write things down and give them back. All right? So this is not just a...
He knows that we don't do anything.
I gathered that from all those blank pages in your workbook. It was pretty amazing. Yes. It's good. Y'all can do a lot of good things in your head. All right, so here we go. So, again, we're going to look at a sample, and then we're going to answer some questions about it. So, here's the sample. A Year 9 class was shown a photo of a person. Some students were shown a smiling photo and some not smiling. Now, this was the same person in each photo, but one time they were smiling and the other they weren't. Then they were asked to estimate the person's age. Okay, so that's the experiment that they were going. So what I want you to think about and discuss in your groups for a grand total of 5 minutes is... what would be the reason behind the experiment? What are you thinking that they're trying to see or measure?
Do we come up with multiple things?
You bet, because there are going to be lots of different ones, right?
Yeah.
And then we're going to share out at the end. So, are you ready?
Yes.
For 5 minutes, go ahead and think and
Okay. I got it.
put some things down on paper and decide what you want to say. So again, now that you've decided on a question, right, based on that criteria, what do you predict are going to happen? What is your prediction? Your opinion.
Yeah, okay.
Okay, so here's our question. What do you predict? Now remember, prediction is just what you think is going to happen, right? But you want to make accurate predictions or descriptive predictions. Okay, so who wants to share?
Me.
Yes.
Okay. I think that smiling makes you look more youthful. Therefore, I predict that the ages guessed for smiling photos will be a younger age than the non-smiling photos.
There you go. So that you think that the effect of smiling will make you feel more youthful, look more youthful. So people are going to guess a younger age for the smiling photos than they do. So, do you think though? Remember when we go back to our question, they were trying to estimate the person's age. Were they just trying to see where you look younger or older in one of them? So your prediction's good, right? It does answer a question, but does it fit what you're supposed to be doing?
I would say yes. But is it not?
Well, it would with a caveat. What would the caveat be? What else do you need to? What do we need to? What's our? We're supposed to be getting close to their age. So would they be? So a person is more likely to look youthful while smiling. So would that make it more and a more accurate guess? Or
Less accurate. Wait, this is a weird thing. This is quite difficult.
yeah, because you have to think about every detail, don't you?
Yeah, but if you're aging yourself by not smiling, then they also might go too old, and then the
Right. So not smiling, they may guess too old. Or smiling, they may guess too young. Well, there you go. There's a prediction based on pretty much what you were saying then, but fitting what the description of the experiment was. So you think my prediction is, if I can paraphrase what you said, that the people who get the smiling photo will guess the age as too young, while the people who get it not smiling might guess too high. Right?
yeah.
Okay? So pretty much what you said, but you just left off the estimated age, right?
Yeah.
So yeah, do y'all agree with that?
Okay.
Okay. Anybody else have something different, or did you all pretty much go along those lines?
Yeah.
Kind of. Now I saw one. I can say it said frowning Any of you changed the facial expression? It says one photo doing what? And the other photo doing what?
Not smiling.
Now, is not smiling mean frowning or scowling or making a face? Be careful when you push. You're not supposed to tell who you are. Be careful not to. Okay, guys, hold on. Be careful not to project too much on what your experiment is, right? Okay, you can say this is my prediction based on what I do, but if it's not really based on what you do, then it's not very inaccurate, right? Okay. All right, that's perfectly fine then, because she clarified frowning. But again, we're supposed to be looking at this scenario. All right? Well, lots of us do, but this is not the time to do it. All right, so now let's look at the next question, okay? Oops, sorry. So we did our prediction. The next question, come on guys. The next question is, what from that scenario, what is the treatment and what is the response variable? What is the treatment and what is the response video? Exactly. I'll take us back to the original. No problem. So treatment and response variable. Okay? So our questions are, what are the treatment and what is the response variable? So would somebody like to tell me what they think the treatment is then? Somebody who hasn't answered before, remember? Yes?
The changing of facial expression. So
The change of... the fact that the expression is changed. So the control would be just a picture of the person. And the treatment would be the picture of the person smiling, right? That's the difference. The treatment is the difference between what you started with. Okay? Okay, so the treatment is the photo with the smiling, right? That's what we've changed, that we want to measure the effect of. Okay? And so, now I need somebody to tell me what the response is going to be. You were very quick. Sorry.
Okay. Estimating people's ages.
Right. The response is... What the response variable is simply what the people say in response to the question you're asking, right? Okay?
So it really is the response.
Exactly. It's literally the response. So how the age, what the guess that they make for the age is going to be the response variable. Okay? Excellent. Okay? Let's look at the next one. Now, think about this. How could you reduce variation? Right? Remember that there are going to be a lot of variables at play here. How could we reduce the variation in our experiment? So think about that. We'll come back to it in just a moment. All right, ladies. So how could we reduce variation? Who wants to volunteer? Who hasn't answered a question already? You realize there are enough questions. Everybody's going to have to say something. Hold on. Raise up something. Yes.
You give them fixed ages, so you give a list of ages, say that person is 20 years or 40 years, and sort of they have almost quiz games.
Okay, so
Yeah.
Multi-choice.
or a scale. So give them multiple choice to see how to have them guess ages so that they can see. And that would be a good way of making sure that they focus in on what you want to see. If they're going to pick an age that was less, without being too outrageous, because what do you know about our audience again? They're very young, right? So how focused might they be? Okay. All right. Yes, you had something over there. You had something over there. I'm sorry, I don't know your name. So.
Oh, no, it's just the random sampling that it's kind of do with.
Random sampling too, as well. Make sure that you make sure your sample is very random. Now we've only got a small population to choose from from year 9s, but we still want to make sure that we do use a good random sample. Everybody has an equal chance of being chosen if in one group randomly.
It's always divided into blocks first by gender and then randomly allocated into control and treatment groups.
Okay.
If the photo was of a man, the boys might be white, or the guessing. Then
So if you have, so you might think of block sampling or randomization using those block treatments that we learned about in the other sections, so that you have an equal chance of males and females, or maybe right in each group, and being able to get to get a good sample there. Y'all might not think about that because you would go to school with all girls, but right, gender might make a difference because it didn't technically say that it was at Queen Margaret, right? Okay, good, all right, excellent. Okay. So, this experiment was an actual experiment that a student did and made a prediction, got some information, and got some results that we're going to share, that I'm going to share with you now. So, here are the results. Now, if you can look at the data, does it look as if they gave a range of numbers or multiple choice or anything?
It looks like a range from
So either like
55.
Okay. Could have given a range, right, of something, but definitely what kind of photos were they using?
Middle age.
Watch out. They were, so they were choosing adults, right? So the photos were definitely of adults.
Yeah.
Okay. All right. So what I want you to do, and this is your homework because we're working together on the rest of it. This is your homework for this section. And remember, I'm collecting it because I need to be able to see that you can do what we need you to do, right? So this is a real assignment. What I want you to do is I want you to take these results, put them into NZ Grapher, and do the analysis. Remember the analysis that we looked at? What were the kinds of things that we looked at? We did a dot plot, then a box and whisker, right? Then you were comparing the means. You did the randomization. You watched the video to learn how to do that, right? Okay. And then, excuse me, to see is this so random that the probability so high that it wouldn't matter what, it's so random that you're going to get the same results no matter what. What was the cutoff for that? Do you remember? The percentage or the probability for that? A probability of over 10%. Remember? So if you get a probability of over 10%, then it really wouldn't have mattered if you did the experiment or not. You would get the same results no matter what. Now you have to do that. You'll do that probability after the randomization, and yes, that gives you 1,000 different times they do the experiment over and over and over. But again, the New Zealand Grapher will do that for you. So make sure that you know how to put it in. So does everyone know how to enter the data? Do you enter it directly into NZ Grapher? What do we have to do?
Excel.
We'll put it into Excel, right?
Do you
And
have to go into order? Like number order?
do the numbers need to be in order? Nope. It's smart enough to figure that out, but what do you need?
Labels, titles.
Do you use NZ Griffin in American?
in
That's why I was wondering.
Yeah. We use something called StatCrunch. Okay? So what do you need?
Title.
What you need titles, and what do you think those
Variable.
what do you think those titles might
X
be?
and Y.
Smiling or not smiling? Variable and something.
Treatment and non-treatment.
Response variable.
Treatment and no treatment. Treatment and response.
The treatment and the response. Right. Good. Yeah. Right?
The
Now,
response is the numbers.
exactly. So, what were the two possibilities that that you could have a picture of? So, you could get a picture of what?
Can you?
Smiling or? Okay. So, that's the treatment. And then the responses would be what?
the
The ages, the numbers. Right, good. So you're going to have two columns with those in there. And then when you import that and pick your variable, remember it says right there when you pick your variable, your first variable has to be the numeric value. Not the treatment, but the numeric one. So make sure you pick it up. Okay? If you have questions, so most of you had used NZ Grapher in the past. Yes, you said that. If you didn't, then you might want to ask one of your classmates because I've never used it. So y'all are going to teach me. All right? So next time we meet, what you're going to do is you're going to bring me a printout of the graphs, okay, with the analysis.
What type of graph is it? Like,
It'll make a dot plot and a box and whisker.
oh yeah, that type of graph.
Right? Remember that? Remember that?
What type of full analysis? I wish I did.
No, it does the analysis for you. Right? All you do is just the information it shows you the analysis. It'll show you compare the means, and then it'll do the probability after you do the randomization. So yeah, there's no math to do here, kids. You just have to be able to get the stuff in there and push the right buttons. Okay? So don't be panicking. Okay. So, but then make the conclusion. Your conclusion is
That this happened.
that if they were more likely to pick the right age if they were smiling, or they picked the younger age, or that the probability was so high in the comparison that you couldn't make a decision. Okay? Now,